Welcome back, everybody, to Flat Irons Tuning. This is another episode of Hey, what's your problem? And we have combed through your comments, and we've got a couple of good ones here. This first one is from YouTuber Dead Zero Grateful. I'm not sure. It says, "Hey guys, I got one for you. I've been chasing a P2443 air pump switching valve stuck code. I have replaced the relay, the pump, and the valve, verified the wiring. What am I missing? Do you know what the pins for the ECU is looking for these codes?" This is a 2009 WRX, and he says the code's been intermittent since 2015, but it's getting more persistent. The car's been stock and then modified previous to him purchasing it, and he has now since kind of gone and modified it again. So this is the part of the secondary air pump system. So there's an air pump that sits on top of the the driver's side of the engine, and then there's a valve on either side of the one going to each cylinder head for that air to go in, and one of those valves apparently is sticking shut, and that's what is throwing this code.
Man.
And he's replaced a bunch of stuff.
Okay. Yeah.
What are your thinking?
You know, really, this is one of those times when you hope you've got a friend with like a power probe or something of that nature where you could apply 12 volts.
Yeah.
Because I think those have like a 2-pin connector or a 5-pin connector, and you could run 12 volts to it and verify functionality.
Right.
And once you've proven or misproven that they don't work or do work, well, then its next step may be replacing parts or digging further in by contacting.
Yeah, and it sounds like he has replaced parts.
Mm-hmm.
But my question here is, were they used parts, like used known good, which like maybe they weren't good, or was this actually a new part?
Yeah.
It says bank. I think he said bank 2 for the 443. So I'm not sure which cylinder head that was. The banks in the DTC codes, the trouble codes, are a real pain, especially on smaller displacement engines. Like a lot of times, like a 4-cylinder engine, especially if it's an inline 4, there is no bank 2.
Right.
So does that actually mean anything or not?
It's hard. Maybe they're banking on you not knowing what's going on.
Oh, somebody's definitely banking on that. That's for sure. But I think when you have a solenoid, I mean, it's a relatively simple system.
Yeah.
And so, like, if you know that the part is good, I mean, that would be another thing, is to remove the solenoid again. Try and bench test it with 12 volts. Can you get it to actually move? Can you verify that if you like follow the wiring diagram, send the power down the right wires, can you get the solenoid to move on the bench, verifying that it's good? Because then that would go back to wiring something along those lines.
Yeah, definitely isolating it from the rest of the car, because I think they wanted to check it in car, but maybe you've got too many other widgets and things in there that could create a false positive or a false negative for you.
Yeah.
So I think bench testing is a good idea.
Yeah, because he had done so much swapping of parts and checking of wiring, I did a little bit of digging, and I confess I went in and looked around the Subaru service manual a little bit. The one other thing that I mentioned in there that grabbed my attention is that there's a relay for the secondary air pumps.
Okay.
And part of the diagnostic, what they recommend if you're going to have trouble, or if you're having trouble with the system, is to check the relay or replace the relay. So if everything else is working, I wonder if maybe it could be a problem with the relay not working. So maybe power is getting sent and the pump is, or the solenoid is functional for the valve, but there's something with that relay that's not clicking and not sending power down.
Yeah, and that goes back to your point about isolating it from the rest of the circuit. Pull it out and then do the testing on it. Apply 12 volts and see if it goes dunk. Yeah. And then you'd know, okay, solenoid's good. Yep. Must be relay.
Yeah, for a lot of systems, we ran into it on the race car once to do with the fans. There's a low speed fan relay, there's a high speed fan relay. If you're having problems with some of these electrical systems, like you could verify the wiring, and everything is there, everything is working. You send power to the fans move, but the fans are turning on. Oh, hey, remember there's all these relays in the engine too. So the wiring and the part could all be fine, but if the relay that is there to like trip and send more power to the thing, or to activate, in our case the fan isn't working, everything is going to check out unless you look at the relay specifically.
Interesting.
So it might be worth looking at the relay too.
Yeah, I'm wondering if you maybe take another relay from it if it's similar to something else and swap it, disabling something else, unfortunately, but at least enabling your solenoid to switch on and off, so you'd know, hey, it's this guy.
Yeah. Well, and on relays, you can actually bench test the relay, because a relay is basically just an electromagnet. So when current goes through it, the magnet is tripped, and then that closes the other circuit.
Right.
So you can send power to it, hear the click, and then verify continuity on the open side of the relay. So that in this case, I'd say would be well worth doing.
Absolutely.
It could, after all this spring damage, it could just be a bad relay.
Oh, that'd be
amazing,
right? But it'd be great on the other side. It'd be really edifying to be like,
yeah.
Hey, it was this.
So if it's a relay, let us know. And if it's not a relay, well, still let us know.
Let us know.
Yeah, to figure out what it was. Yeah, good question. So thanks for sending that one in. We had, let's see, the next one here is from our live chat, a customer named Steven. So he asked an interesting one, and this kind of ties into one of our previous, hey, what's your problem questions. He's been using a tuner for a long time with his STI, and he's now getting a P0420 code.
Oh, no.
So this is the rear, or the cat inefficiency, rear 2 sensor inefficiency code. And what he's asking about is that, he's not had trouble before, but it sounds like he's gotten a tune recently. The car is lightly modified. He has a Cobb GESI downpipe, or a downpipe with a Cobb GESI cat in it. So the GESI cat, that's one of the highest quality catalytic converters, aftermarket catalytic converters that are out there. A lot of times they're, I guess now they'd be like 45 state legal, 46 state legal, something like that. So they're really good cats typically, but he's still getting this P0420 code. So as we talked about previously, this is one of those codes, because it's to do with an emissions system, that tuners cannot turn off anymore post, basically green speed update and that sort of thing. And so he's wondering why he's now getting it, and if there's anything else that can be done, because he has, this GESI downpipe that he's had good luck with before, or that he's not had the issue with before.
Right.
So given all of that, I mean, what was your initial thought there?
Well, my first thought is that poor cat is cold, and it's not like, your cat is, pawing at the door. This is, your catalytic converter. But if it's cold, it's not going to function properly, and so then you're not going to burn away into the hydrocarbons, and then you're going to trip a light. It's going to be just, hey, we're dirty, and you can't get that cat to effectively light off as far downstream as they've got it in the early designs. And so I suggested that to him, and I said, hey, what design is it? And he said, yeah, it's the far, it's the one with the cat over by the O2 sensor. I was like,
yeah,
man, I hate to tell you this, but you're going to need to get another downpipe, probably a carb certified unit. Suggested the MagnaFlow unit because it is carb certified.
Yeah.
OEM design with, better flow characteristics than the OE unit, different flow characteristics than the GESI cat unit.
Sure. And so it could be just, well, I guess let's go back and explain what we're talking about, the cat lighting off and the cat position.
Okay.
So the catalytic converter, it has to be hot to start doing its job. And what its job basically is, when light off is literal, it finishes combustion. It finishes burning off, unburnt fuel and stuff like that. That's how it does its job, and it has to be hot to do that. So what has happened a lot is emissions have gotten stricter, or manufacturers have tried to reduce and continue to reduce the amount of emissions. The cats have kept getting closer and closer to the engine. So what they found is that they really want the cat as close to the engine as possible, so that it will get hot as quickly as possible, so that it can do its job.
Right.
You put that cat a long way from the engine, it might be to the point where it's just barely getting warm enough to do its job, or it takes it a long time to do its job. On older cars, like probably from the 90s or something like that, where a lot of times, even from OE manufacturers, would put the cats further away. Something where you couldn't start the car up and just drive straight to the emissions if it was 2 miles away.
Right.
You got to drive the car for like 20, 30 minutes, get everything good and hot before you go to emissions, because that's what gets the cat up into its operating temperature, operating window.
Yeah.
And so that could be something that's going on here. Maybe it's just not happening fast enough to make the computer happy enough.
It could be slow. I'm wondering, because at the testing facilities here, I have to turn my car off.
Yeah.
If it sits for a minute, everything cools down, and because it's so far away, it gets too cold.
Yeah.
Like you're saying, it just switches too slowly.
Yeah.
It can't light up in time before they put it on the roller.
Yeah. The one other thought that I had in reading through this problem that I think would be at least worth a try is to wrap or insulate the downpipe before the cat.
Yeah.
So, you have, the turbo's up here, the downpipe comes down, and the cat's way back here. Well, you could wrap the whole section of the downpipe right after the turbo, which is going to hold the heat in that exhaust more, going to get more heat to the cat.
Yeah.
Maybe that would help with its efficiency. Maybe that would help it line up sooner. Maybe it would make it happier.
It really couldn't hurt.
$50 in header wrap will get the job done.
Yeah.
If it does work, you're also keeping your engine bay temperatures down because you're keeping more of the heat in the exhaust versus let it kind of radiate into the engine bay. And if it doesn't work, you're only on $50 versus now having to seek out, a carb-approved downpipe like the MagnaFlow or something like that. Worth a try.
Yeah, definitely can't hurt.
So we got a Discord, and Turbowski asked about putting a swaybar in a swapped 2.5 RS.
Okay.
And this, I think, is a GC.
Okay,
Yes.
So it's an early chassis with
it's an early chassis
swap.
So this is not that uncommon of a problem, or it's more complicated than it would seem. So this does come up, or has come up not infrequently, and it's because when you're putting a turbo engine in a GC car that didn't come with it, obviously you've got to put all the engine in and all the exhaust. Well, the path of the exhaust is different because you have an up pipe that goes up to the turbo where the natural aspirated cars don't, which requires a different subframe.
Okay.
So you have to run a turbo subframe to be able to do a turbo swap into a GC, but then that subframe means that the stock non-turbo swaybar and such doesn't fit anymore, and then it becomes a quandary of what do you look for, what do you need, what can you make fit.
Okay.
So the starting point is if you're going to do a turbo subframe, or if you have a turbo subframe in a GC, you need a swaybar that will fit the turbo subframe. Now, a lot of times the easiest path there is to get a swaybar that is designed for a GC, WRX, or STI, because those cars exist out. Subaru made plenty of those. My favorite go-to for that is Whiteline, because Whiteline's based on Australia. Australia had all the GC, WRXs, and STIs, and so they made suspension components for all those early STI and WRX models. So they have sway bars that are designed for that chassis with the turbo subframe. And I believe, to the best of my knowledge, all of the turbo subframes in the GC and the GD era, whether they're JDM or USDM, the sway bar fitment is the same. So as long as you've got the turbo subframe and you've got a sway bar for a turbo car, you should be okay as far as the initial part of fitment. But DP, are there other fitment considerations to take into account here?
Well, there could be. I mean, would you start thinking about like our end links and our control arms? Because fortunately, this isn't just like it's not just a modular piece where you can just put this piece in and then this piece and then profit. Right. We need to look at if we've got like aluminum GD control arms or if we've got any of that kind of thing going on.
Yep. It's actually kind of related to the problem of like a WRX wagon sway bar versus WRX sedan sway bar for the GD chassis, because those two cars are different widths.
Right.
The sway bars are different, and it's because of the width. And now that's the same thing with the GC, especially if you're going with the USDM subframe.
Right.
The US models, I guess wagon or sedan, the subframe is the same, but the reason they have different sway bars is because of the different chassis widths. So the GC is a narrower chassis width. So you have to have the sway bar bent so that it'll bolt up to the subframe properly, first and foremost. But then you have to have the length so that where it comes down, it mates up with the lower control arms, so that you can properly attach an in-link from the lower control arm to the sway bar.
Right.
If you have a mismatch, like too wide of a bar and the narrower mounts on the control arms, the in-link can be kicked out at an extreme angle one way or the other. And then that can cause some weird binding issues and stuff. So most of the time, it depends on which lower control arms you have as well. Usually, guys with the GCs are sticking with GC control arms, I would say most of the time, or they're getting like the JDM GC, WRX, or STI control arms, which all would have the same swaybar mounting location on the control arms, which would mean you'd want, again, a GC, WRX, or STI swaybar, which I believe is also the same as the WRX wagon through 2002 to 2007. Safer to go with the GC, but I think the wagon works.
Wagon life.
Yeah. But then where it gets even more complicated, for anybody that we haven't lost yet, is if you're going with a GD sedan with control arm on the GC, because then the GD sedan arms have mounts further out because they use a wider swaybar because they have wider track width.
Right.
So like say you're putting on 2005 STI lower control arms, well now you would probably need a 2005, well you would need a 2005 STI front swaybar because that's going to be a wider bar that's going to line up properly with the mounts, for the inlinks.
Interesting. So yeah, I mean, it really sounds like whoever had this car before was like, you know what? There's a whole mess of things here.
Yeah.
And not realizing what they got into, and so just kind of left it alone. But yeah, it's a whole system. Like when you do any kind of a swap, you really can't just put tab A in slot B and then hope for the best.
Yeah, and the best advice here, where it becomes really challenging is if you buy a car with a swap done, if you're not the one that's picking all the parts and putting the parts on, because once you get this far out of the box, it really helps to know exactly which parts you're picking from which platform to put together in this car. If you're not the one that's doing it, then that's where it really helps to like have some buddies that have similar cars or like cars that are known quantities. Like, hey, Tim's got an 05 STI and it's basically stock, it's unmodified, so you can measure, how far from the ball joint to the mount for the in-link is on the control arm. What's the overall length of the control arm? How wide is the sway bar? And then compare it to whatever you might have. That will tell you, if the GD sedans are wider than the GCs. The 2002 to 2007 sedans wider than the 2001 and older GC chassis. So if you've got a bar that's narrower than a GD bar, then that's a GC bar. If you've got a bar that's wider than your GC bar, then it's a GD bar. Just you have to kind of do some comparison and process of elimination to try and whittle down to what you've got. Or worst case, if you buy some parts and it doesn't quite fit, well, look at why it doesn't fit. All right, well, this bar, it bolts up to the subframe, but the inlinks are canted out like crazy, which means, okay, my sway bar must be too wide or the mounts on my control arms are too narrow. Okay, so I must have GC arms in the GD bar, GD sedan bar, something like that.
Yeah.
And then look at your options from there. There's a lot of measuring and troubleshooting involved with that, but when you get that far out of the box, that is kind of what you have to do.
Most definitely. And another pro tip there, if you are in the middle of a swap and thinking you might get rid of it or not, take notes. Have a book of what you're doing. I mean, my Forester, STI Pinks, the 04 STI 6-speed, 04 hubs, Brembos, R180 diff, I've got notes for all the stuff in my car for that reason.
Yeah, we were in chat with a guy this week that had a rally car that was using 5x100 hubs, or 5x114 hubs, that it was in a GD, so it should have been the press-in bearing, but it wasn't a press-in bearing. It was the cartridge bearing that bolts to the knuckle. So it was a WRX, so obviously an STI swap had been done, but he got a new knuckle, and it didn't match up with what he had, and all of a sudden now, time is running out to get ready for the next event. Okay, well now we've got to do some measuring, do some comparison, try and figure out, okay, what do you have? Which model is it from? Or did somebody do something crazy out of the box? And and so keeping notes. Yeah, when you're doing a swap, the more notes you can take, the better. Put it into a spreadsheet.
Yes.
Because at some point, 2 years from now, you is going to be really, really thankful that present you took all those notes, because it's going to make finding that sway bar or those replacement inlinks or whatever way easier, because you're going to be able to remember, this is the combination of parts they put on the car. This is a good one. This is a question about pad knockback. In the Brembo 6-piston calipers, the ones that came on the 19 and up STI and the 2018 Type RA. So Stumpy Truck is having an issue with pad knockback.
Okay.
And so he's asking about if there's any knockback springs that he could put on with those calipers. So his his car, I think, came with these.
Should have.
Yeah, his is a 19 STI, so his car came with these calipers from the factory, and he's having pad knockback issues. All right, so my first question is, DP, when you hear pad knockback, how would you define that problem?
Well, I would start to classify it as effectively the pad isn't lining up where on the caliper with the piston, so it's kind of offset or it's set at a funny angle because something else has acted on it. Mm-hmm. Usually it's something where I'd start to think about lateral runout.
Yeah.
And I'm going to think the old term was warped for rotors.
Sure.
But it's a thickness variation between the inboard and outboard steel is starting to do this at a really, really small level. It's multiplied 2.54 to 1 or something crazy from the inboard of the hub to the outside of the rotor. So it becomes quite a magnified force, and those pads, there's only so much that spring pin can do.
Yeah.
So, I'd start with asking the person, well, what do you really have going on? And I'd want to see proof of pads being wonky, or if they could possibly take the wheel off after driving it and see where we're at.
Mm-hmm. So, and what's interesting here, I guess where I was going with this is pad knockback. I've heard people use that term to describe a few different problems.
Right.
So there's another one where I've heard called pad knockback, which is where you are backing the car up and you hear a click.
Yeah.
And then you go forward again and you hear another click. And that is usually the pads moving to the front or back of the caliper. Mm-hmm. That's not what we have here, but I've heard it referred to as that, and that would be a different thing. With knockback springs, is the first thing you were thinking of is, okay, well, is he talking about the spring over the top of the brake pads to keep them
the butterfly
located in the caliper? But in this case, what we're talking about is inconsistent brake pedal. So his symptom that he's feeling is the brake pedal, the first pump is not really getting the car to slow down. He has to double pump the brakes. Mm-hmm. And on the second pump, then the brakes really grab and catch. And what he says here is that it's caused a few pucker moments, and he's actually having to adjust his driving style to basically accommodate for a double pump of the brake. So he's having to hit the brakes and then come back again before he gets to his braking point to make sure he's got enough time to stop, which is not confidence inspiring.
Yeah.
And so to that end, something what would typically cause something like that is that the pads are getting pushed back into the calipers, so that it's you bleed the brakes for the first time. You have to pump the brakes up to get the line pressure, to the point where now you can actually apply pressure to the pads and then bleed the fluid out. That's kind of what he's running into every time he's coming up to a hard stop, and that is not confidence inspiring at all.
No, that's scary, because especially on those brakes, those are huge brakes. That's got to have massive brake torque. So when you have the moment, you got to really make sure you get on those binders. But no one wants to double brake for brakes. Now brakes doesn't even sound like a word anymore.
Right. Now with warped rotors, just like you're describing, that is one thing that can cause the pads to knock back like that, because the rotor is to a minor degree warped, and so that warpage is pushing the pads back, and so then you basically have to repressure the pads every time you're coming to a stop.
Right.
Now what's interesting for Stumpy Truck is that he's using Giradisc 2-piece rotors. So the 2-piece rotors, in terms of warping, that it's harder to warp a 2-piece rotor.
Oh yeah.
Because the outer ring is attached to the inner hat through these springs that kind of take up a little bit of that movement, or they can accommodate the heating and cooling much better than a one piece of all the same material rotor. So is it possible that you can warp 2-piece rotors? Yes, it can certainly be done. That's not a challenge, but it can be done. It definitely would be something to check, but it's something it's harder to do. And so I'd say it's plausible, but I wouldn't, maybe there's something else going on.
Yeah, in this case, if I were to get into some diagnoses on this, I would definitely pull the wheel, I'd pull the rotor, and I'd just take a micrometer and just set that point right on that hub, and I would just turn that hub and see what kinds of lateral runout I've got, because I feel like we've got an issue where there's a wheel bearing that's not properly seated, it's not tight anymore.
Could be.
And, I mean, it sounds like it's a fairly new car, but if something unfortunate has happened, hit a curb or something else has happened where, like, you hit a speed bump really hard or anything like that, or one of these pucker moments didn't go quite as to plan, that could damage the wheel bearing. Yep. And then as such, you could see on, like, a micrometer on that hub, you just see that little needle move a little bit.
Well, and you could use that same tool to measure the runout on the rotors as well. So you can measure the rotors for runout first and see if they're basically true, if they're flat, or if you've got runout. If you've got runout, with the Gyrodisc, you can replace the rings. Yeah. Put on the rings, maybe the problem goes away. But if not, you measure the hub and just check the bearing for any kind of play. We actually had, I can't remember, maybe 5 years ago, we had an issue on Pikes Peak with Scott driving the car where the symptom was exactly this problem. He would have to double pump the brakes. But the crazy thing is it was one corner and one corner only. It was the same corner all the time. This was in testing through the whole week. Bled the brakes till the cows come home. I think we replaced the master cylinder. Did all sorts of stuff to try and solve it from a hydraulic standpoint. From fluids and maybe it's an air bubble, and it was always the same corner. And he basically just learned, okay, well it was a very tight corner where it's like a tight corner after a long straight. So he had to basically give himself extra stopping room, double pump, get through it, and the car is totally fine everywhere else. Got the car back, a couple weeks later, car's up on the lift, and just start poking and prodding at it, looking at things, grab the wheel and just give it a shake, and clunk, 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 clunk. It was a bad wheel bearing in our case. So why or how can a bad wheel bearing cause pad knockback?
Well, in the same manner, because that wheel bearing is going to allow for that magnified play where it's going to move back and forth. And, even if it's, you're talking like thousandths of an inch, but then multiplied out to the entirety of the rotor, which is a ginormous rotor on this car's case. Mm-hmm. It's just moving like this and moving like this, and so the rotor's doing this and doing this.
It just pushes those pads back.
And those pads just get pushed back because they're just along for the ride. They're riding on those little sliders, and they're just like, hey, well, this is what we're doing now.
Yeah.
Because they don't have any way to really be back to re-centered.
The thing with the Subaru is oftentimes it's harder to detect a bad wheel bearing than you would think. Because Subaru's being all-wheel drive, there's an axle going through all of the hubs, which means you have the tension between the axle and the axle nut squeezing the wheel bearing the whole time. So, on a front-wheel drive car, like on the front, where there's no axle, but there's no tension on that bearing, usually when those start to go, it's way easier to detect. But that tension of the axle nut, it kind of can mask a failing wheel bearing to the point where it actually makes it somewhat difficult to detect. Even, up in the air, and if you're applying pressure and stuff to the wheel itself, wheel and tire, but then you take it apart and then it falls completely apart or something like that.
Oh yeah. So
that would be definitely something to check. And honestly, you're tracking the car, it's a safety issue. It takes away from a lot of the fun, and it's something you're having to drive around. If you've checked everything else out, everything else is checking out fine. I would honestly say, replace your wheel bearings. Yeah. Because, on this car, being a cartridge is relatively easy to do, and then that they're in good shape. And then, if that fixes the problem, in our case, it had gotten bad enough that, especially once we got the wheel bearing off, it was like, holy cow, this is not good. But then that did fix the problem. And to that end, what is the best practice for replacing a wheel bearing? Because that is also it's not as simple and straightforward as it might seem. If you do it wrong, you can basically damage or destroy a wheel bearing in the process of putting a new wheel bearing on.
With a hammer. No, wait. That's not right.
No.
Okay. Well, for reals here, don't use an impact.
No.
Hand tighten. Don't remember.
Probably the best practice is not even as you're trying to get it up close to the final torque. Don't use an impact at all.
Just do it by hand, nice and slow, nice and easy.
Yeah.
I don't remember what the torque spec is right offhand.
Don't quote me on this. I'm pretty sure it's 162 foot-pounds.
Okay.
Check the service manual, but I think it's 162.
But then once you're at your proper torque, #stake the nut.
Yeah.
That's the other part of this.
Okay. Another great point, stake nut. because they can rotate.
Yes.
Yeah, check the stake nut. Make sure that your stake nut is still in place, because we did that too. We had a stake nut start to rotate on us, which can happen if you reuse them, because so the stake nut, you've got the little gap like this, and then the nut comes over and you have to hammer it into that gap to prevent the possibility of the nut from turning. But if it's not staked properly, staked deep enough, what have you, that nut can start to spin. As soon as you relieve that tension on the bearing, that could cause the bearing to fail too. Yeah, we've gone through a lot of wheel bearings.
Well, I mean, but that's the plight of like the Pikes Peak car and stuff.
True.
When you're playing that hard, it's easy to go through things at an expedited rate.
Yep. Yeah. But yeah, the not using an impact and getting it up to the proper torque, those are the two key pieces of the equation. And where I'm pretty sure it's 162 foot-pounds is I remember at one point we had the torque wrench that went up to 150 and it wasn't enough. And so I had to go out and get the higher torque wrench so you could properly torque it to 162 foot-pounds. So I know that it's more than 150. But a lot of people don't have torque wrenches like a 250 foot-pound torque wrench.
Right.
Well, you really need to get it up to that torque for it to have enough squeeze to properly hold that bearing.
Absolutely.
So if you are just guessing at that torque, that can cause its own set of problems too.
Oh yeah, I mean, because you're like, oh, it's close, and then because you're like, well, I got to 150, that's only 12 foot-pounds off. It's like, no, that thing is effectively still loose.
Yep, and if it's not tight enough, then the wear can be exaggerated or quickened. And if you go too tight, then there'll be too much drag. The bearing will degrade quickly. That can cause accelerated wear too. You really have to be in that Goldilocks zone. You got to have the right tool and you got to do it right the first time. If you're going to replace a wheel bearing, that's what you've got to do.
It sounds almost unbearable with that Goldilocks.
Well, yes, it could be. Replacing a wheel bearing to only have to go in there and replace it again is definitely unbearable. Yes.
Absolutely. Do it nice, do it twice is not the way we want to do it on a wheel bearing.
Definitely not. I mean, because in this case, this person is tracking the car. He's using, basically very sticky tires, putting a lot of stress on those wheel bearings. Wheel bearings on Subarus are something you really want to give a really good look at. Probably at least once, maybe twice a season at least.
Yeah.
And when you're starting to have symptoms like this, this is a good call to really give a really good look at that system. And again, sometimes like the wheel bearings are relatively inexpensive. That is basically preventative maintenance, preventative safety.
So, absolutely.
Yeah. All right. Well, I think that's it.
That's it.
That's all the questions we have for you today. As we always say with this show depends on your questions. So if this sparks any thoughts, or if you've got any questions for us, leave them in the comments below. Leave them in the comments on our Instagram or our Facebook pages. You can also email us at the contact us link on the Flat Irons Tuning website. Send them to us through our Discord. Or you can open a live chat. We're always on live chat. A lot of times it's DP here, the beard, that you get on live chat, and you can ask him. And if it's a good one, we'll set it aside and we'll bring it up for the next podcast. So, yeah, thanks very much for listening. Really appreciate your support as always. And until next time, as always, stay tuned with Flat Irons Tuning. Specifically. So, in that case, we're going to pause. Okay.
Oh, gee. Do you want help?